Hi, I'm Rhett Jesse, and today we're going to talk about the Metrix 5580 signal conditioner and the SW5580 switch. Now for the demonstration, I'm going to be using the SW5580 switch, and we're going to show the relay functionality. The only difference between the SW5580 and the 5580 is the switch functionality. Otherwise, the signal conditioning, all the software, everything's virtually the same. And the differences are just the relays. So I'll talk about the SW5580, but realize that everything I talk about with regard to the signal conditioning and the 4 to 20 and the configurability also applies to the 5580. So keep that in mind. All right, let me tell you about my setup. What I have is a Hardy Shaker 903, HI 903, and I've got an SA6200A accelerometer connected to it. I have it connected with this cable to the SW5580, and you can see that connection here. It's connected to the A- and A+ connection. All right. The SA6200A has an output of 100 millivolts per G. What we're going to do is we're going to bring it into channel 1 as I've shown you already. And then what we're going to do is we're going to have output of acceleration out of channel 1, but integrated velocity output out of channel 2. And so that's how we're going to set up our software. So in order to do that, I've got to connect the 5580 to our software. And I'll do this using this cable. It's just a mini USB to USB connection. We'll connect it. And then I've downloaded the free software from our website, and I have loaded it on my computer. Now I'm connected with the USB. I'm going to go ahead and say connect. And with the unit powered, I should be able to read its configuration, how it's presently configured. All right. So right now I have one accelerometer in, and it's set up for acceleration on channel 1 and impact on channel 2. I'm going to change that configuration so I get integrated velocity on channel 2. So I'm going to go to change configuration, and I'm going to take off impact, and I'm going to basically set it up for integrated velocity. And I'll go 0 to 1 inches per second. Or in metric units, that would be 25 millimeters per second. And I could set this up for metric units just as easily as English units. And I can set it up for peak or RMS. I'm going to set it up for peak. All right, so that's our setup. I'm going to go ahead and send that configuration over to the device. And it asked me for a password. I don't want to do this again, so I'm going to go ahead and put in the password. So I enter. And what that will do, that's a SIL requirement, by the way, safety integrity level functionality. You have to have a password, and you can set up that password however you'd like it. But just remember what that password is, because once you change it, I won't be able to fix it. All right, so keep that password to yourself, but keep it secret. I went ahead and put in the password, and now it's updating the device. We'll let it go ahead and load, and then we're going to do a demonstration with the shaker, and we're going to see the output. I'll explain the rest of my setup here in just a minute. Now, most of these wires that you see here in the setup will be usually inside DIN rail mounting, and it'll be in some sort of conduit, so you wouldn't see these wires. But this is what, if you were wiring to the relays, the 4 to 20, all at the same time, you'd have these, and they would be typically concealed inside a cabinet. So let's, before we begin, we're going to go ahead and check our relays and see what they're set at. For channel 1, which is G's, and we have a 0 to 10G scale, we have an alert at 1G and danger at 3 Gs. And for the integrated velocity, we have 0.25 inches per second peak and danger at 0.5 inches per second peak. You can also see on this screen that I have is that we have all the time delays set at 3 seconds. Now you can set it up to 5 minutes up to 300 seconds if you want. It just depends what you want to do with the system. All right, you can set it down to 1 second, or you can put it at 0 seconds, just immediate alarm. It's just however you want to set up that time delay. I'll keep it all at 3 seconds today. We also can set these to latch mode, so if the relay hits, it will stay latched until you hit the reset. So you can go latching or unlatching, or non-latching, latching or non-latching. All your settings that you have currently in here are listed here to the left. That's what's in the system now. Now if I changed anything, like if I change 2.5 inches per second, I change it from 3 seconds to 6, I can send that and that will update on the left. So you can see your current settings are always going to be on the left on the blue. And so we'll let that update. And when you'll see 6 seconds there. After it goes to 6, I'll change it back to 3 and we'll do the demonstration. All right, so now it's set at 6 seconds, as you can see over here. I'm going to go ahead and set it back to 3. All right, let me explain the rest of my setup here. I have a lot of wires coming out of here, but that's just so we have all the functionality of the system. All right, we have the sensor coming in. We have the power coming into the device. We have the 4 to 20 coming out, and that 4 to 20 is going over to this device right here to the left. Okay, that's channel 1. Channel 2, the integrated velocity, is on the right. Now it should be right around 4 milliamps, plus or minus 5%. Well, it's well within that. It's almost right at 4, where it should be. All right, and then we have channel 2 coming out into this device over here. Over here, we have both of our relays from channel 1. We have alert and then danger. And I have it on ohms. So right now, it's normally open. So with normally open, you're going to have overload on each of the ohm meters. So when these contacts shut, it's going to go to something less. It's going to go to either short or show something like 10 ohms or something like that. We'll be able to see that. So we have our values loaded. Let's go ahead and let's look at what we have on the display and on these devices when we increase our vibration level. And we're going to increase the vibration amplitude from 0 up to 0.2, which will be about 20% of full scale. So 0.2 times 16 milliamps is 3.2 milliamps, plus 4 gives us 7.2 milliamps. So we're looking at a signal at about 7.2 milliamps at 0.2 inches per second. Let's just see what happens. We've got, we'll just go ahead and increase to 0.2, a little overshot just a little bit. And here we have 0.2 inches per second at 60 hertz. And we should see the same thing on our screen, which we do. And we see close to 7.2 milliamps. It has to be within 5%, which it is. 5% is 0.8 milliamps, and it's well within 0.8. So let's go ahead and increase it to 0.4. When we increase it to 0.4, we're going to go past 0.25. Let's go to 0.3. We'll go to 0.3. We'll have the 0.25 inches per second alarm come in. We'll see that with a flashing yellow light. And then we'll go up to 0.6. And we'll see the danger alarm come in. On both of those, we don't have the voltmeters connected to the relays, but when we switch to acceleration, we'll see that. Let's go ahead and increase this to 0.3 inches per second. All right, and you can see the alarm came in, flashing yellow. That's what we expect. We see 0.3 indicated. 0.3 times 16 is 4.8 milliamps. 4.8 plus 4 is 8.8 milliamps. We have 8.2, which is close. It's within 5%, and that's what we want. Let's continue to increase until we get the danger alarm. Let's go to 0.6 inches per second. Okay, that's 0.6. Danger alarm comes in, flashing red. And that's what we expect from the system, so it's behaving exactly what we want. Now at 0.6, like I said before, we're only about 0.5 Gs, and we'll see that if we switch to Gs on the shaker. We're at 0.6 Gs. almost the same. I guess at 60 hertz it's very close. So that makes sense, so that's good. There's no acceleration alarm. What we'll do now is we'll go back down in amplitude, and then let's increase the frequency up to 200. You can see the alarm's clear because we're non-latching. We had that set. And let's go ahead and go up to 250 hertz. Nice thing about the Hardy shaker, the HI903, is the amplitude doesn't change when you change the frequency. It goes back to what you set the amplitude at. So we were at 0. I'm going to go ahead and increase this to 1G. And our alarm was set at 1G, so we'll go to 0.9 Gs and there shouldn't be an alarm. Okay, 0.91. And there's no alarm, it's still green. Let's go to 1.1 Gs and let's see the alarm come in. And when you see that, you'll see that the alert, which is here, you'll see the resistance change when that relay changes state. Now this is a mechanical relay, I expect the short. So let's see if that really happens. Let's go to 1.1, about 3 seconds. Relay change state, see the flashing yellow, we're in alert. And you can say, okay, we have a short, we don't have any ohms, and that's because it's a mechanical relay and not a solid state relay. So it's a short, and that makes sense. You can see that the danger relay hasn't gone yet, and it's still in the OL position, the overload position. So now let's, as far as an ohm state concerned, let's go ahead and increase this to 3 Gs, or 3.2 Gs, and get the danger alarm to come in, and we'll see the other relay change state. Oh, what's interesting is the alert just came on for velocity at 250 hertz. And that makes sense because we're up at 0.39 per inch per second right now. Okay, we're at 1.58 Gs. So I'm going to go up in Gs now, all the way up to 3 at 250 hertz. Okay, the danger velocity just came in, and right now we're at 0.63, and you'd expect that. We had that at 0.5, so let's go back to Gs. And let's continue to increase it up to 3.1 or 3.2, just so we exceed the alarm. Go to 3.2. 3 seconds later, you see flashing red, and you can see we're close to a short. Okay, that's when the relay's shut. Just a short circuit now that the relay went on. And that's what you want to have. You want reliable relays that change state when you've set them per the time delay. And that's the demonstration for how the accelerometer works and integrated to velocity and how the relays work along with it. Hopefully this makes sense, and we look forward to you on our next video. Thank you.